You recently published a blog looking at this gas phase-out plan that the independent systems operator here in Ontario was asked to look at in the context of an anti-nuclear organization that calls themselves the Ontario Clean Air Alliance, gaining a lot of political momentum, getting cities and municipalities to sign on to a pledge for a gas phase-out. The systems operator was therefore enticed into looking at it. What did they find? Did they consider a Pickering refurbishment?
So the IESO study, in response to these resolutions by a bunch of municipalities here in Ontario, issued a study that said that it would cost on an annual basis $5.7 billion per year.
This is for a population of, like, Ontario is a population of what, 11, 13 million or something?
15
million.
perhaps.
Just so our listeners have some context.
Yeah. So look, our current grid is on an annual basis is about 22 to 23 billion dollars. So the idea to eliminate gas in already a very low emission grid was always going to be expensive, right? Because we already have one of the lowest emission grids in the world already because of mostly relying on nuclear, about 60%, hydro about 25-30%, wind and solar is another 10%, and then you've got another 10% of gas. There's no coal on the grid, right? I mean, that was the biggest achievement in
gas
Ontario.
Right now is really just used for peaking at times of.
That's exactly it. It's 10%, right?
Yeah.
That's right. And so in order to replace that, and the reason that we need to replace it was that 10 years ago, the state-owned utility generating company, it's called the Ontario Power Generation, decided that it would refurbish one of its two nuclear plants, right? So it would refurbish Darlington rather than Pickering.
Right.
And what IESO determined was that rather than both. Yeah. And so what they did is that they said, look, as a result of that coming offline, the replacement of those 22 terawatt hours would come exclusively from gas.
Right.
And it would be basically not new gas plants, not new assets, but basically ramping up the capacity factor of those gas plants from about 10% to about maybe 35 or 40%, which would result in an additional 8 megatons of carbon.
Which
right?
we were looking at the numbers recently, and Canada has been a real laggard in terms of the G20 at reducing its emissions, much less so than its European counterparts or even the U.S. I think partially because of our oil sands development in Alberta. But so far from our peak in 2007, we've come down by 22 megatons, and we're going to be backstepping a third of that, 8 megatons. So we're going to lose a third of our progress as we apparently are in some kind of a race to stable at 1.5 and reduce our emissions by like 30% or something compared to 2005, just for context.
Well, and that's exactly it. And so in this context, they said, okay, well, look, if we assume that Pickering will not be refurbished and therefore we will have additional gas generation, what would we have to do to replace that gas generation with zero emitting sources? And so they built up this, IESO did this study, and they built it up with some storage, some wind, some solar, an SMR, et cetera. But anyway, bottom line is they came up with a bottom line number of about $5.7 billion, which would result, and plus payments to the gas generating plants for legally using the state power to actually shut them down.
You mean government intervening in energy, Edgardo? Is that what? Really?
That's exactly it, right? With the compensation, right. like the German government has had to compensate the nuclear companies
and the coal companies, right?
And the coal company, and we're not talking about this is like, so you're paying double, right? You're having to build the additional capacity to replace it, and you're having to compensate those dirty capitalists that happen to have invested, right, in clean energy, right?
Right.
And so that's what's going to happen here as well. And so we're coming up with, if you remember our second episode, Chris, about carbon abatement costs. We're coming up with carbon abatement costs in the order of $500 or $300 per ton avoided if we do this as suggested by IESO.
Right.
Huge amounts. I mean, our carbon tax now is $50,
right?
So we're paying 7 or 8, 10 times as much as we need to. There's much cheaper ways to do this. So what I did is that I took away that assumption of what would it cost to actually refurbish Pickering, and what would be the actual monetary cost, and would it be cost beneficial in terms of having a lower carbon abatement cost? And in both instances, the answer is yes. It's going to be cheaper because you're refurbishing rather than building new assets, and you're maintaining gas and not having to build the gas station, the new replacement, and you're not having to compensate, gas plants for shutting them down.
So this is a maintenance plan essentially. It does keep some gas on the grid as compared to the full
Right.
gas phase out, but it still keeps us at a highly competitive, deeply decarbonized grid. And maybe we can get rid of the remaining gas with some new nuclear and a pumped hydro storage or something. But just to
Down the road.
yeah, but to sort of preserve ourselves, because we're about to take a huge step backwards in terms of our
That's exactly
our
it.
emissions
Yeah.
progress.
So what it is that, and if you look at the actual carbon abatement costs, right, where you avoid those 8 million tons of additional carbon, given the actual price that you're paying for them,
Right.
it's still half of what it would otherwise be if we were to take the ISO replacement scenario.
And the ISO replacement also was quite clear that there would likely be blackouts and brownouts as a result of this plan.
Oh yeah, no. I mean, they recognize that the phase out of gas by 2030 is totally unrealistic, and that even, and especially if you were going to go for exactly a zero emitting carbon, they would have to build. They modeled and costed out a grid battery, a storage battery that doesn't exist right now, right? There's
Maybe the
the
biggest
large.
in the
I mean, it would be the biggest in the world, right?
many
And
hours
so
of
even
storage?
then, what's that?
How many hours of storage?
I can't remember, but it would be the largest in the world. It doesn't exist right now.
Right.
It's billions of dollars. It doesn't exist right now, and even then, it would be insufficient to actually keep the lights on.
Right.
Based on their own modeling. So they put up the straw model where it says, look, it's super expensive. It's not feasible, and even if it was feasible, it wouldn't be reliable.
And the technology doesn't exist yet for that size.
And if the technology doesn't exist.
Okay.